Hello and welcome in mechanical system design subject. Today we will see the steps in design of multi-speed gearbox. So here the decide the number of speed steps Z and number of transmission stages, that is capital N. How that number of speed steps Z is calculated and how the stages of the speed steps or gearbox is made, that we are going to see here. So the number of speed steps for a given value of Rm and phi can be calculated from the formula Z is equal to log to the base 10 log to the base 10 Rn into phi divided by log to the base 10 phi. So this is the formula. From that we will get the Z value. So consider Z is the number of speed steps. Therefore, Rn is the speed range and phi is the geometric progression ratio. So also from the phi is equal to Rn raised to 1 upon Z minus 1. We take the log on both sides. So log to the base 10 phi is equal to 1 upon Z minus 1 log to the base 10 Rn. So by rearranging that, you will get the Z is equal to log to the base 10 Rn into phi divided by log to the base 10 phi. Now capital N is the number of transmission stages. So let P1 is the number of speed steps in first transmission group. P2 is the number of speed steps in second transmission group. Similarly, after third stage, we have a P1 by P2 by P3 speed steps, and finally we have a Z speed steps after n number of the transmission. Therefore, Z is equal to P1 by P2 by P3 by dash 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 up to Pn. In order to obtain the required speed steps Z using minimum number of gears, it is necessary that all the stages should have some number of speed steps for equal speed steps. Therefore, P1 is equal to P2 is equal to P3 is equal to Pn. Therefore, Z is equal to P into P n times. Therefore, Z is equal to P raised to n. Therefore, taking log on both sides, we'll have a log to the base 10 Z is equal to n into log to the base 10 P. So from that we will get the n, that is the number of transmission stages. N is equal to log Z upon log P. Then generally the value of P is either 2 or 3. So in above equation it is not giving integer value. Then modify equation as Z is equal to 2 raised to n1 by 3 raised to n2, where n1 is the number of stages with the 2 speed steps and n2 is the number of stage with the 3 speed steps. If Z is equal to 27, then n is equal to log to the base 10 27 by log to the base 10 3. Therefore, 3 will be the n. Then if Z is equal to 8, then also n is equal to 3. Then if Z is equal to 12, then n is equal to 2.26, not possible. Therefore, n is equal to 12 is equal to 3.58. It is also not possible. Hence, Z is equal to 2 raised to n1 by 3 raised to n2 is considered. So the speed of electric motor NEM is required. So speed of electric motor, that is NEM. So what is the purpose of speed of electric motor? To decide the speed of input shaft of the gearbox and the mode of transmission from electric motor to input shaft. If the required speed of input shaft of the gearbox is same as that of a motor speed, then the motor is directly coupled to the input shaft. If the required speed of input shaft is different than the motor speed, then they are connected either by, or these are connected either by the belt drive or gear drive. Next point is a kinematic diagram or gearing diagram of the gearbox. So the construction of kinematic diagram includes deciding the number of shafts in the gearbox, deciding the number of teeth on each gear, on each shaft, then deciding the arrangement of the gears on each shaft, and deciding the number of teeth on each gear. To construct the diagram of the gearbox, it is necessary to know the distribution of speed on the input shaft, intermediate shaft, and output shaft. So it can be obtained by using the structural formula, structural diagram, ray diagram, and speed diagram. So the structural formula, what is meant by structural formula? So it is the mathematical expression giving the distribution of the speed steps in each stage and the number of spindle speed steps by which two adjacent speed steps are separated. So the total number of spindle speed steps are calculated by using the formula Z is equal to P1 dot P2 dot P3 up to Pn. A more elaborate expression for Z is Z is equal to P1x1 dot P2x2 dot P3xt dot Pnxn. So this formula is called as a structural formula. This will give the mathematical expression for the distribution of the number of speed steps in each stage and number of spindle speeds by which two adjacent speed values of each stage can be separated. Now the where x1, x2, x3, xn are the number of spindle speed steps by which two adjacent speed values of particular stage are separated. Then here x1 is equal to 1, x2 is equal to p1, always x3 is equal to p1 by p2, x4 is equal to p1 by p2 by p3, xn is equal to p1 by p2 by up to dash dash pn minus 1. So in this way we can calculate the structure, or we can develop the structural formula. So the feasible structural formula, for structural formula to be feasible, the product pk into k must be a factor of z, that is z upon pk into k must be an integer number. If it is not an integer, the structural formula cannot be converted into the structural diagram. Next is the structural diagram. The structural formula which describes the kinematic structure of the gearbox are supposed to be or are represented in the form of a special graphs known as a structural diagram. So here in diagram you will get the representation of structural diagram. Let n is the stage of the gearbox, z is the total number of speed steps in the gearbox. So here how to draw the structural diagram. So there are some steps are given. So first step is to draw the n plus 1 number of vertical lines. So here number of vertical lines in the diagrams are called as the n plus 1 value. Then draw the z number of horizontal lines, means number of horizontal lines equal to z. So the draw the z number of horizontal lines at interval between the equal to log to the base 10 5. So this is the interval or the space of the two speed rays or two speed lines, that is a log to the base 10 5. Then total range is the Rn, that is a log to the base 10 Rn. So the first vertical line is represented at the first shaft, which is the input shaft. Second vertical line is a intermediate shaft, and third vertical line is acts as the output shaft. So for example, say if n is equal to 3, z is equal to 12, the structural formula will be 2 1, 3 2 and 2 6. So here p1 x1 is represented the step or stage between input shaft and intermediate shaft, that is stage number 1. And for second shaft to third shaft, this is represented by p2 x2. So that will be called as a second stage. So this is a structural diagram for two stage gearbox. So in this way we can develop the structural formula, and we can draw the structural diagram for the kinematic design of the gearbox.